In this video, I'll show you how to create custom footprints, schematic symbols, and new components in Kicad. Are you designing your circuits like a caveman?
Ooh. Ooh, shiny. Huh? What? Oh yeah, the future.
Make your projects look smart and professional by using a custom-made PCB. Ordering is as easy as uploading your Gerber file and choosing your design preferences. Order 5 PCBs from as little as $2.
So next time you need a custom-made PCB, think about buying them through JLC PCB. They help support content creators like me making videos like this possible.
So in this tutorial I'll be making a footprint for the DW01-P IC. The footprint for this IC is a SOT-23-6, which is what I'll be making in this tutorial. Now in order to make a footprint, we need all the measurements for the pin spacing and where the pins are located. So in my case, I've downloaded a data sheet for the package that I want to use. If you can't find the data sheet for your specific electronic component or whatever you're trying to mount, you can do the same but with a pair of calipers or a ruler and take down all the measurements you'll need. So first I'm going to click on Footprint Editor. Then I'm going to click on New Footprint, and here we need to enter a name, so I'll put SOT-23-6 is my footprint name. So displayed with the footprint is the name of the footprint, and we also get a reference, which if we double click on the reference, we can enter in any details we want, and we can also choose what layer we want the text to appear on, and by default it's on the front silk screen. So for instance, I could call this DW01-P, which is the name of the IC I'll be using. So I'll hit OK. So the first thing we need to do is choose the correct size grid we'll be using to lay down our footprint. And in order to choose the right size grid spacing, we need to go back to the data sheet. What I'm looking for in the data sheet is the pin spacing or pin pitch, and here we can see it is 0.95 millimeters center to center between the pins. If we go through the default options for the grid spacing, there isn't any for a 0.95 millimeter grid spacing, so I'll need to create a custom spacing. So I'll leave the origin at 0 and 0, and here is where I edit the grid spacing, which is all the white dots you see in the background. So I'll enter 0.95 millimeters and 0.95 millimeters again. We can then click on our grid menu and then scroll down to the custom grid we just made. So now I'm going to select Add Pad, and then I'm going to place one pad down. Press Escape to go back to the cursor, and if I double click on this pad I've just laid down, we open up the properties for this pad. So here we have many options, and I'll only go over some of them. For instance, pad type. Depending on what type of component you're working with, you might need a through hole, it might be a surface mount, etc. So I'm going to choose SMD, which is surface mount. So here we can choose what shape pad we want to lay down, and I'm going to choose rectangular. And here I can change the dimensions of the pad. So I'm going to go back to the data sheet, and the data sheet shows a pin width of 0.4 millimeters, and I'll have my pad slightly wider than the pin, say something like 0.6 millimeters. So we've got measurements for both the X and Y axes. So the X axis goes across the screen like this, and Y is vertical. So I'll have my pad length at 2 millimeters, and pad width will be 0.6 millimeters. If we click on local clearance and settings, we have a few options here. Pad clearance adds an exclusion zone around the copper track, so I'll show you what that looks like. I'll just add 1 millimeter, and you can see that adds a border in which no copper tracks can go into this exclusion zone apart from any that connect directly to the pad. And this can be useful if, for instance, you're working with high voltage and you need a certain amount of clearance between this pad and any other copper tracks. I won't be needing any pad clearance, so I will go back and edit that to 0. You can also add solder mask clearance, solder paste clearance, and so on, but I don't need any of these, so I'll just leave everything on the default and hit OK. So first I'm going to lay down pads for 1, 2 and 3. So I'm going to highlight my pad, hold down Control and press C to copy. It'll ask us select reference point for the copy. I'll just select the center, and then we'll hold down Control and press V. Place that one there and place that one there. Now I need to reassign numbers to these pads. So starting from the top, 1, this one will be number 2, and this will be 3. So now I have one row of pads. I need another 3 pads over here, but before I lay those down I need to work out how much space to add between the rows of pads. Back at the data sheet we can see that the IC is 1.6 millimeters wide, so that's how far I'm going to space my pads away from each other. So I'll left click, drag a box over the pads, hold down Control, press C, select a reference point, and then press Control V to copy them, and I'll just lay my pads down over here. I'm going to go over and select the measure distance tool, and this allows us to measure any points within the grid. So I'm going to click over here and then click over here, and we can see that the spacing between my rows is too close. It's 0.95 millimeters. So I'm going to highlight my pads and move them over one row. Go back to the measuring tool. But there's a problem. I need my rows 1.6 millimeters apart, and you can see here it's 1.9 millimeters apart because the pads are snapping to the points in the grid. So in order for me to space the rows 1.6 millimeters apart, we need to edit the grid. So I'm going to click on Edit User Grid again, and this time I'm going to edit the x-axis by putting 1.6 millimeters in, and I'm going to leave the y-axis at 0.95. Press OK. So vertically we have 0.95 millimeter grid spacing, and then horizontally I now have 1.6 millimeter grid spacing. So now I should be able to move my pads into the correct spacing, right? Well, let's have a go. If I drag my pads over and they snap to the next point in the grid, they are way too close, and if I move them one over, they're too far apart. So why is this? It's got to do with the origin of the pads. When I go to move a pad, you can see some white crosshairs show the origin of the pad I'm moving, and currently the origin is located in the center of the pad. So when I go to move it, I can only move it to the center of my grid spacing. So in order to change that, we can go back into the properties of the pad, so I'll double click on it. And in the preview window, you'll see these blue crosshairs show where the origin of the pad originates. So under Shape Offset, we can move the origin. So my pad length is 2 millimeters, and currently the origin is in the center. So if I move the shape offset by 1 millimeter, you can see the crosshairs are now on the edge of the pad, or I could enter -1 millimeter and then it's on the other edge of the pad. So now when I go to move my pad, you can see the white crosshairs show the origin, and the edge is now snapping to the grid, which is exactly what I need. So now I'll edit these pads and change their offset origin. So for this row of pads, I subtracted 1 millimeter so that the origin is on the right hand side. I need to do the opposite for this row. I need the origin to originate on the left hand side, so I'll add +1 millimeter. And now when I go to move these, they all snap to the correct point on the grid. So now click on the measure distance tool. We can see that the gap between the rows is 1.6 millimeters, which is what I need. And if I measure the pin pitch, in other words center to center on the pins, I have the correct spacing also, 0.95 millimeters. So you notice I have duplicates of pad numbers here, and that's no good. Each pad needs to have its own unique pin number. So if we go back to the data sheet, so you'll see the pin spacing in the data sheet goes 1, 2, 3, and then 4, 5, 6, and I need to replicate that in my footprint. So I'll double click to open up properties again, renumber this one to 4. Right, so now my footprint is complete. Now we need to save it under a library, and you can save it under one of these pre-existing libraries that is in Kicad, or you can make a new library. And to do that, we just right click over here, click on new library. So now we can choose where to save the library and also what we're going to call it. So I'll call this library custom components, hit save. And now we can choose whether we want to save the library as global or project. And what this means is global, the library will always show up in all your projects. If we choose project only, the library will only show up in that specific project we're working on. So basically, in other words, I always choose global and then press OK. So now we go up to File and we click Save As, and then we can choose what library we want to save the footprint to. So I'm going to scroll down to the library I just made called Custom Components and then press Save. And if we expand the Custom Components list, we can see our footprint is now listed under there. So now we can go ahead and close the footprint editor. Now we need to open the symbol editor. So first we need to choose where to save our symbol to. So you could choose from the pre-existing libraries or right click and make a new library. But since my IC is for battery management, I'm going to choose to save it under the default included library for battery management. So I'm going to go up here and click create new symbol. And I'm going to name my symbol DW01-P. Default reference designator, so this is the letter followed by a question mark. So U is appropriate for the type of IC I'm working with. Number of units per package is 1. Can leave all the rest on their default settings and just hit OK. To move the references or names about, just place your cursor over them and press M to move. So let's have a quick look at our toolbar over here. So these 4 tools are used for drawing graphic lines or circles. So if we select, for instance, the rectangle tool, we can left click, move our mouse out, and we can make a box however big we want. Similar for the circle, just select a point, left click and drag out, and you create a circle. The arc tool, you left click, drag out, left click again, and then you can move your mouse in or out to make the arc smaller or larger. Double click to end. And then lastly we have our lines tool, which we just left click and drag wherever we need a line, and to end the line we just double click. Right, so I'll get rid of those. Now when we're designing a symbol, we can make the symbol look like anything we want, because remember, a symbol doesn't have any real world measurements, unlike the footprint. The symbol is just that, it's just a symbol to show us how the part interacts with our circuits. So we can draw whatever we want in the symbol editor. Personally, when I'm designing my symbols, I like the symbol to visually represent the component that I'm using in the real world, and it just helps me visualize how everything is laid out in the designing process. In a nutshell, the IC is nothing more than a rectangle, so that's what I'll be drawing as my symbol. Or of course you could stick to drawing classic symbol designs. For instance, here I'll draw a symbol for a diode, and there is our diode. So really the world is your oyster when it comes to choosing how to design your symbol. So I'm going to choose the rectangle tool, and I'm going to start up here and make a box. I'm then going to right click on the box, select edit rectangle options, and choose fill with body background color, and that just fills in the background color of the rectangle so it looks like a solid body. Now when I was designing the footprint, this was the data sheet I used, and that is just to design the footprint. Now I need to look up the data sheet for my specific IC that I intend to use. So here is the data sheet for my DW01-P battery protection IC. And now we need to scroll down to the pinout of the IC. So here we can see the top view of the IC, and we can see the pin numbering system. And we can also see over here we've got the pin numbers and also their symbols. And then lastly we have a description of what each of these pins do. So for example, let's start off with pin number 1. The symbol is OD. So now we need to come up here and click on Add Pins to Symbol, and then left click somewhere to open up pin properties. And here we're going to enter the pin name. So for my example I'm going to choose OD. The pin number is 1. We can choose the electric type, whether it's input, output or bidirectional. I'm just going to choose bidirectional. We can choose what the line looks like. I'm going to just stick with the default line. I'm going to leave everything at the default settings and press OK. And now we can choose where to add this pin. So I'm going to place it right here and left click to place pin. So now I've got all my pins laid out, but there is an issue. Some of the text for the pins is overlapping. Now there's two solutions for this. We could go back into pin properties by double clicking on it and choose the size of the text so that it's smaller. And that way we don't have the text overlapping. Or we could draw a bigger rectangle so that we have more room to work with. Right, so now I'm happy with how my symbol looks. I'm going to go up to Edit Symbol Properties, and I'm going to left click on Footprint and then click this little icon over here. And now we can browse for the footprint we created earlier. So I'm going to look under Custom Components, and then here is the footprint I created, SOT23-6. We can see it there. So now I'll go ahead and double click on it to select it. And you can see there is the reference for the footprint. Everything's loaded correct, and I'll press OK. In grey text you can see we have the footprint name, just as a reminder of what the footprint is. Right, so lastly we need to save our work, so I'm going to click on File, Save As. I'm going to scroll up to Battery Management. Enter in whatever name you want to call the component and then click on Save. Now you can see under Battery Management it has successfully added it to the library. So now we can go ahead and close the symbol editor. So I've just made a blank new project. I'm going to open up the schematic, go over to Place Symbol, and then I'm going to search for DW01, hit OK, zoom in and place the symbol, and then you can go ahead and start placing your connections and using your brand new components in Kicad. If you found this video useful, please give it a like and let me know what features you'd like to see explained next. Also, a big thanks to my supporters on Patreon. You guys rock. See you in the next one.